Got the man with the plan right here. Bring it right.
Next, the very important question for the BCom, data science and BSc, same two persons. So, lack of memory property for hypergeometric distribution. A constant situation before and after happening of an event in the experiment is known as lack of memory. If k is the time of happening of an event, x is the exact time of happening of the same event. Uh, Next, then p of y is equals to t, x greater than or equals to k is equals to p into q to the power of t, where y is a waiting time, so y equals to x minus k. So here what they are asking you to prove the geometric distribution PMF. The PMF of the geometric distribution is given by P of x equals to P into q to the power of x, where x can takes the values from 0, 1, 2 and so on infinity. P is always lies between 0 to 1, q equals to 1 minus p. Now consider the LHS value from the question. Probability of y equals to t given x greater than or equals to k. P of y equals to t intersection x greater than or equals to k whole divided by p of x greater than or equals to k. So the conditional probability we are applying. Probability of a given b is equals to probability of a intersection probability of b divided by probability of b. So from that, since y equals to x minus k, we are aiming for x, that is y plus k. So here we have to find out y equals to t, so x equals to t plus k. Substitute that value over here, x equals to k plus t or t plus k, x greater than or equals to k. So probability of x greater than or equals to k. So here you have to consider each and every value. So what is the common in both, that is yx equals to k plus t. So consider the numerator p of x equals to k plus t means from the distribution p of x equals to p into q to the power of t. No, here x equals to k plus t. So p into q to the power of k plus t here we are writing. Next, p of x greater than or equals to k, that implies summation p into q to the power of x, that implies p into q to the power of k, and in place of x we are substituting k. So p into q to the power of k plus 1, p into q to the power of k plus 2 and so on. If you common that one, p into q to the power of k, 1 plus q square plus q cube and so on we are getting. Okay. Next, the p into q power k is equals to 1 minus, sorry, into 1 minus p whole to the power of minus 1. So p to the power of 1, p to the power of minus 1 gets cancelled, q to the power of k. Substitute this value in the given function. So LHS value, this is p into q to the power of k plus t divided by q to the power of k. Q to the power of k, q to the power of k gets cancelled. This is in the form of the p into q to the power of t, which is our RHS. Next, hypergeometric distribution. Let us consider a box consisting of capital N balls, in which m of them white balls and the remaining red balls. If n balls are selected from the box in which x are white, remaining n minus x are red, then its probability is given by, so p of x. This is a hypergeometric distribution, mcx into n minus mc n minus x. Next, whole divide, this is the numerator value, denominator ncn, where x can takes the values like this. So moments of hypergeometric distribution. The PMF of hypergeometric distribution is given by, so we are writing mcx n minus mc n minus x whole divided by ncn, where x can take the values. So consider mu1 dash is equals to e of x equals to summation x into p of x. So this is also can be written as x into m cx p of x we are substituting. So this can be written as x into m divided by x of m minus 1 c x minus 1 into n minus m c n minus x. So we have one property in our combinations. So what is that combinations property is by putting outside the value of m divided by ncn, summation remains same and m minus 1 c x minus 1 n minus the numerators you can add. So if you add them and the denominators also you can add. So m minus 1 plus n minus minus m plus m minus m gets cancelled. Next plus x minus x gets cancelled. So it will become n minus 1 c n minus 1 like this. So we are just changing the ncn value and we are removing the summation also. So if you add this property, then you can remove the summation. So n minus 1 c x minus 1, this is the mean of which distribution mn divided by n of that is mean of the hypergeometric distribution. Next similarly you have to find out the mu2 dash also. So mu2 dash value is also you can e of x minus x1 plus e of x property. By applying mu2 dash you are going to get m of m minus 1 n of n minus 1 divided by capital N of capital N minus 1 plus mn divided by n. So if you substitute that value in the variance, then you will get the variance as this mn divided by n minus m divided by n of n minus 1 of n minus n. So as you can see here, this is also be the same. Okay, so please try to understand about the hypergeometric distribution, and we don't have any another extra calculations of like mgf cgf cf for the hypergeometric distribution. Thank you. This is very useful for the BSc data science and uh, BSc statistics people also. Thank you.